All right, on this last problem we'll work from this section. It's kind of like our lab in that you're given a wave function, not a picture but a description. And so he's telling me that it's got a period of 33 meters a second. He's going to want me to write the wave function. So we're having a negative x direction with a speed of 30, so that's the speed of the wave. And at 0, 0, it's at 2 centimeters and it's moving down. In other words, a piece of string vibrating up and down is moving down at a speed of 4 meters a second. So the period's 33 milliseconds. From that you get the frequency, and from the frequency you get your omega. The velocity is 30. Using your wave equation, you can find the wavelength. Velocity is v over t. So we get the wavelength from that, velocity and period. And from that we get our k. So in our wave function, k and omega, we have both of those. We're going to use the other information to get the amplitude. Now remember, the velocity of the string, not the wave, but of the string moving up and down is the derivative of y, so we get omega a cosine. So we're going to use those initial conditions to find a and phi. If you plug in 0, 0, you 0x, 0t, so all you're left with is your angle. So the amplitude, the position's O2, which is a sine phi. The velocity, we said, was down, minus 4, omega a cosine phi. Now that's a standard thing in anytime you're using trig functions, to have to solve those two. And what we do is first you use cosine squared plus sine squared is 1 from trig class. So that's then just I write it this way. I take the y and square it, which will be a squared sine squared. I divide the v by the omega and square it, so I get a squared cosine squared. Factor out your a squared sine squared plus cosine squared is 1, and so you've got your amplitude if you take those two numbers. So I do those and get that number, and then that's a squared, so I take the square root and there's my amplitude. In order to find the phase, what you do is divide the two, so you'll get tangent. So you divide the two, you'll have sine over cosine, which is tangent. Your a's cancel. I need to bring the omega up and then take the inverse tangent. So that's how I get my phase. Now remember, the inverse tangent always has sometimes it's wrong by pi. So what I did was I said, all right, let's plug those numbers, 0, 0s, into using that phase and amplitude and see what we get for y and see what we get. So if let's take this out for just a second then, and you see it doesn't work. I get a minus 2, and if I say, well, we know it's off by 180 sometimes, so we go F, Control G, we'll add 180 degrees to it, or pi, however you want to do it, and that'll give me a new phi. And that'll give me my y of O2, and round it off a minus 4, so yeah, that's right. So that's the phase I put in as my answer. And so now I have everything I need, and he wanted us to write it out in 3 decimals for 3 significant figures. So there's your a times your sine of your omega. The plus is because he said moving to the left. There's our omega rounded, k rounded, and our phase constant rounded. All righty. That should be helpful in finding your phase on your lab.